Now we have two vectors here, a 3i minus 2j and b 2i plus j. We're going to find the scalar projection of a onto b. Now first of all we need to find the unit vector of b. So to do that, if you remember, it's going to be this vector 2i plus j over the magnitude of b. That's the square root of 2 squared, which is 4, plus 1 squared, which is 1. So that equals 1 over root 5 times 2i plus j. Right, so to find the scalar projection of a onto b, it's the dot product of a with the unit vector of b. And that will be equal to 3i minus 2j times 1 on root 5 times 2i plus j. So we simply multiply these guys together. So I'll take the 1 over root 5 out the front. That's root 5 times, this will be 6, and then this one minus 2. So that's going to give me 4 over root 5. It's the scalar projection of a onto b. Projection vectors are number 2. In this particular case here, we have to find the vector projection of b onto a, of b onto a. To do that, first of all, we need to find the unit vector of a. And to do that, remember, we go, that's equal to I minus j over the magnitude of a, which is going to be the square root of 1 plus 1, which equals I minus j all over the square root of 2. Now we need to find the scalar projection first. So to do that, we write that as b times I minus j over root 2, and that's going to be equal to 2i plus 3j over, just over 1, times I minus j, put brackets around this, root 2, and that becomes, when you multiply these two together, you're going to get 2 minus 3 all over root 2, which is minus 1 over root 2. Right, now to find the projection, vector projection on this one, we simply multiply this by the unit projection of the unit vector of b. So it's minus 1 over root 2 times I minus j over root 2, and that's going to give me minus a half of I minus j. Now what that is, you can see, is that as you project this down here, this is the unit projection this way, okay, and it's going, and that will be minus a half of 1 minus j. So that would be going back the other way, half of that vector, I minus j. It's done. Number 3, we have got a equals 2i plus j and b equals I minus j. We have to find the projection of a perpendicular to b. Now, first of all, we have to find the projection of a onto b. So a onto b. So to do that, we need to find the unit vector b. So b unit vector is equal to I minus j over the square root of that one squared, 1 plus 1, and that's going to give me I minus j all over the square root of 2. Now to get the scalar vector of a and b, so that will be simply equal to this 2i minus j. So a dot b is going to be equal to 2i plus j times I minus j all over the square root of 2. That gives me 2. minus 1 over root 2, which is just 1 over root 2. Now the vector projection of A onto B will be equal to simply the unit vector A dot B times this, which is 1 over root 2 times I minus j all over root 2, which is a half of I minus j, which is this one down here, half of I minus j. Now let's have a look at this, because we want to find the projection of A perpendicular to this one B, okay? So to do that, well, we'd see that from a given diagram that CA must be equal to CO plus OA. So CA must be equal to CO plus OA. So CA is equal to OA. Now COOC is minus OC. Now OA, as we know, is just A, and the other one is minus OC, which you just worked out. So the one here, which is 1/2 of I minus j. A, we're given as 2I minus j, or plus j, sorry. That's minus 1/2 I. This is going to be plus 1/2 j, which gives me 3 over 2I plus 3 over 2j as your vector, CA.